Hi kiddos, I'm hoping that if you are watching this video, that means that you were able to watch our how-to video on how to create an account in Spiral, and that you should hopefully be watching this in Spiral. When we use Spiral, that, like I said before, is going to allow us to go ahead and put our answers directly into the video instead of having to go back and forth between a Google Doc. There are going to be a couple of lessons that we will need to do that, but luckily today is not one of those. So since this is our first video, I'm going to keep it really simple. Also just reviewing things that we didn't really get too much of an opportunity to do, and that's actually a really important thing in science, and that's measurements. Measurements are very important because they allow us to collect information. They allow us to collect data. Now, as you know, there are two different types of data. We have what's called qualitative data, and then we have quantitative data. So qualitative, I want you to think of the word qualitative. What word do you hear? Qualitative. You're probably thinking of quality. And so quality is basically like you're just describing what you see, right? So like if I were to look at this water, for example, if qualitative data would be, well, it's colorless, it's a liquid. But when we're talking about quantitative data, again, we hear the word quantity, which means numbers. They're measurements. They're things that are very, very specific. Now, quantitative data is really important because it allows us to tell our audience very specific information. If we go back to this water, right, and I say, oh, well, this is cold. Well, what I feel is cold might be different than what you feel is cold. You might have more of like a cold tolerance than I do, right? Especially think about somebody that lives in Alaska. They're like, oh man, it was hot today. And then somebody that lives maybe in like Guatemala says, oh man, it was hot today. They're probably thinking about two very different temperatures, right? And so when we get measurements, it allows us to be very specific and let our audience know what exactly it is that we are talking about or what information we want to let them know. And so today we're going to go over how to take three very important measurements. We're going to go over volume, we're going to go over temperature, and we're going to go over mass. So I'm going to show you the tools that we use for each. I'm going to show you how to actually gather that data, but most importantly, we're going to go over the unit. Units are important because without it, it's just a number. If you remember in class, some of you guys would be like, oh, 57. It'd be like, well, 57 school buses, 57 strawberries, right? What is it that you're letting me know? Because if you say, well, this water is 57, I don't know if you're talking about the temperature. I don't know if you're talking about the mass. I don't know if you're talking about the volume, right? If you tell me 57 degrees, that's very different than telling me 57 grams. And so we're going to go over these measurements today in order to make sure that as scientists, we're able to convey very, very specific information. So just make sure that you keep watching the video for the next demos. All right, kiddos, so here is our next part. The very first measurement that we're going to talk about is volume. Now this is a graduated cylinder. I'm sure that we've seen these in class before. This one is very cool because it has super, super clear intervals. Usually the ones that we had in class, if you can see, was more like this clear right here. But before I actually show you how to take a measurement, I need to tell you really quickly that this graduated cylinder allows us to take the volume of a liquid. Now, volume is basically just how much space something takes up. And so in class, right, we learned that anything that has matter takes up space. So a cup takes up space, our little brothers and sisters take up space, right? Our car takes up space, but we can't exactly fit those into this graduated cylinder. When we use a graduated cylinder for volume, we are very specifically only measuring things that are in the liquid phase. So here is one of the things that we're going to measure in a second. In order to, again, use a graduated cylinder, they must be in the liquid phase. What phase do things need to be in to be measured in a graduated cylinder? Say it if you know it. That's right, the liquid phase. So on this graduated cylinder, I do want to show you the different intervals that we have. There's a whole bunch of lines, and every single one of those lines is a count by one. There is, however, a very easy way to get your measurements a little bit more quickly. If you notice these very, very long lines right here, they have a number next to them, right? This one has 50, a 60, a 70, and an 80. If you notice, those all count by what? By tens. So these super large lines let you know that you are at a 10. And then right next to it, it very conveniently gives us what measurement that is. So if my liquid went up to here, I know that it would be a 50. So then once we go above that 10, we have these smaller lines, and then we get to this medium length line here. Now this one doesn't have a measurement next to it, but these are actually by fives. So we know that this medium line is in between a 50 and a 60. So since it counts by 5, we know that it's 55. Same for here, we have this medium line here. It's in between the 60 and the 70. So we know that this one must be 65. These little lines here then go by ones. So for example, if my liquid ended up being like right there, right, that would be 50, 51, 52. So let's go ahead and actually practice this. I'm going to pour our liquid into our graduated cylinder. Let's hope nothing spills because then I'm going to have to film it again. So when we are taking our volume, we actually are looking at something called a meniscus. Say meniscus. Meniscus is a curve that the actual liquid makes at the top. The reason that it makes a curve is because the liquid molecules are very attracted to the plastic sides. So they kind of start to stick to them, which makes it look like this curve that we're seeing here. It's a little hard to see. I will try to raise it up and get it closer to you. But we do kind of start to see a little bit of a curve. And so what happens occasionally when you're looking at this curve is that the sides are actually higher than this bottom part of the curve. When we measure volume, we measure from the bottom of the curve. We never measure from the top because that is just the extra molecules of the liquid that got really attracted to the side. So what I'm seeing here is, if I go to the bottom of that curve, right, it looks like we are at 25. So again, it almost looks like it's hitting that 26, but we're measuring from the bottom of the curve. Let me see. There we go. You always want to make sure that you get to eye level, because if you look at it from above, see, that looks a lot different. You always want to make sure that you get to eye level. So this one was 25 milliliters. Milliliters is our unit. For this section, I'm going to take the volume of the liquid, but I'm going to make a mistake. Your job is going to be to figure out what mistake that I made. So let's see, I'm going to go ahead and stand up. And it looks like that volume is hitting that medium line in between 70 and 80. So I'm going to say it's 75 milliliters. What mistake did I make? If you said that I was not at eye level, you are correct. I stood up, which makes that line look like it's hitting the 75. But if I actually was to get down at eye level with the liquid, we can see that the bottom of our curve actually hits the line right underneath. And so if we go and count, we know that we are at 70, 71, 72, 73, and the bottom of the curve hits 74. So the volume of this liquid is 74 milliliters. What I'm going to do now is I'm going to show you another graduated cylinder, and you are going to take the volume. This is your graduated cylinder. Please go ahead and answer, what is the volume of this liquid? If you answered 48 milliliters, then you are correct. We see that the biggest line that it hits beneath is 40, that medium line is 45, and we can start counting from there. 46, 47, 48 milliliters. So this was a very quick demonstration of how to take volumes of liquids. The next measurement that we are going to talk about is mass. Now, mass is the amount of matter that is in an object. It's basically how much stuff is in something. Now, mass is measured in grams. That is the main unit that we use to measure mass. Mass is different from weight. I know that when we go to the doctor, they make you step on a scale and they take your weight. That's different from mass. Weight is just kind of a measurement of how gravity acts on you. Mass is actually counting the amount of stuff in it. You'll learn that difference a lot later, but I just want to let you know that mass and weight are not the same. And when we measure mass, remember we use the unit grams and it's shown as a little g. The tool that we use to measure mass is a balance. Now, obviously, you've seen these in class. We use these quite a lot during our conservation of matter labs. And when we use these, we want to make sure that we're taking off that big cover, but also making sure that we take off that little cover as well. Sometimes it has it, sometimes it doesn't, but we want to make sure that that comes off because if we don't, our measurement is going to be very inaccurate. Two things that we really need to make sure when we turn them on. You turn it on and you let it go to 0. As that happens, you're making sure that you're not putting anything on your balance. If I were to do this again and I were to turn it on, but this time actually put something on it, that initial measurement is still 0. But we know for a fact that this does not measure 0 grams. And if we were to take it off, we would see that we have a negative mass, and that is not possible. You want to make sure that it's completely free of anything until we get it cleared to 0. If this were to accidentally happen, it's okay. You can actually just press this T here, and that clears everything. That's also really helpful if you want to measure a liquid or a powder, right? We can't just put just water freely onto here. So let's say that I wanted to measure water. I need to keep it in a container, but I don't want the weight of the mass of the container. I just want the mass of the water. So I would put my container first. I would clear it so that now it's 0. And from then on, anything that I measure, it's simply taking the mass of the water. The mass of the container is not included. So it's a very fun trick to do. And then you'll notice that you were able to do that because you end up with a negative mass. The last thing that you need to double check is that you are in the correct units. See that little g? That means that it is measuring it in grams. This M here can actually change that. So if we were to press it, now we are in ounces. That is not a little g, that is not grams. Should we take the mass right now? No, because it's not measuring in grams. If this were to happen, you just keep pressing M. Sometimes it might say mode until you get back to G. Am I on the right one? No, I'm not. Even though it's a little g, there's an N after it. That's not grams. That is a different unit. I want to do it until I get back to G, and now we're safe. So let's go ahead and take our first measurement of mass. All right, so go ahead and look at that balance. What is the mass of this item? 16.8 grams. Please make sure that you're adding your unit. Remember, if you don't have a unit, I don't know what it is that you are measuring. So let's go ahead and take this off. I'm going to start this from the beginning, and I want you to tell me what my mistake is. All right, and so it looks like the mass of my crystal is 0 grams. What mistake did I make? Yep, I put my object on too soon, and now it's not actually taking the mass. What can I do to have this go back to 0? Yep, I can hit the tare button, or I can turn it off and back on. That just takes a little bit longer. All right, here's our final object. What is the mass of this object? Yep, 139.1 grams. So this has been a super quick video of how to take mass, and I'll see you on the next one. Our next measurement that we're going to talk about is temperature. So when we're talking about temperature, this is something that we all, I'm sure, are very familiar with. In the news, it tells us what the temperature is for the next day or the following week. When we get sick, right, one of the first things that doctors do is take our temperature. So we're going to be talking about temperature, and the unit that we're going to be measuring it in is degrees Celsius. So this is what degrees Celsius looks like as a unit. This little tiny circle is a symbol for degrees, and then the capital C is for Celsius. Now, I'm definitely sure that when you see it on the news or sometimes at the doctor, they actually tell you degrees Fahrenheit. Degrees Fahrenheit is also a measure of temperature, but it's the way that we do it in the United States. In the rest of the world, they use degrees Celsius. So when we're in science, we're actually going to use degrees Celsius because there are more people that use it, which means that our information can reach a larger audience. And the reason that I'm telling you this is in order to take temperature, we use a thermometer. So this is a thermometer. Let me just pull it out of its case. This is one kind of a thermometer. This is a glass thermometer. Now, this is probably not the thermometer that you're most used to seeing. You're probably used to seeing a digital thermometer. Now, I had one ready for a demonstration, but Octavio is very sneaky and took it. So I can't show it to you, but basically it's kind of like this phone where when you take the temperature, it shows you the numbers digitally here. It's not very hard to use, right? Because you would take the temperature either in your mouth, in your ear, on your head, however it is that that thermometer does it, and then it would appear on the screen. So as long as you can read numbers, you're able to know what the temperature is. This is a little bit harder, which is what we're going to be, which is why we're going to be practicing it today. Now, when we look at this, I want us to notice that there are two sides with numbers, right? As if this wasn't confusing enough with our graduated cylinder, now we have two sides. The reason I'm showing you this is because those numbers mean different things. This left side, you can see it has an F. Can you guess what F stands for? It stands for Fahrenheit. And then this other side has a C. Do you think you can tell me what the C stands for? Say it if you know it. Right, Celsius. So this side will tell us the temperature in degrees Celsius, and if we read it from the left side, it will tell us in degrees Fahrenheit. Which side should we read? We should read from the right side in degrees Celsius. And the last quick thing I'm going to show you is it has this little red stopper here. A lot of them hopefully should have it. Sometimes they go missing. But the reason that this is here is if you notice that red stopper is a lot wider than the actual thermometer, so that if it falls, the red thing hits the surface and not the glass thermometer. Because this is glass, it can break, which means that we need to be very, very careful when we're using it. So we're going to go ahead and get our first liquid. Just for safety, when you put it in, you want to make sure that you are holding it until it hits the bottom. You don't want to just like smash it in. That can be very dangerous. It can crack the thermometer. We want to make sure again that we're being safe. So the very awesome thing, oh no, there we go. The very awesome thing about this thermometer is that the graduations or the intervals on the Celsius side is exactly, sorry, I'm trying to get it to focus, is exactly like the ones on our graduated cylinder. So it has that really big line, right? That much bigger line that has the tens, so 40, 50, 60. It has that middle line that's a little bit larger. We know that counts by 5, so that one there would be 45. And then those little lines in between count by ones. This is not true on the Fahrenheit side. See, the big lines here do count by tens, but we don't have a medium line, and we only have 4 little lines. Those little lines count by 2. So again, that's for Fahrenheit. We want to focus, however, on the Celsius side. So right now, it is taking a temperature, even though it's not in liquid, it's taking the temperature of the room. So let's see if we can figure out what the temperature in the room is right now. So we see where that red line stops, that's the temperature. We're going to look, remember, at the right side. So that very first line on the big line on the bottom is 10. I'm going to count up 1, 2, 3, 4, 5, 6. So our temperature in here is 16 degrees Celsius. What might my mistake have been if I said it was 61 degrees? Yeah, I was looking at the Fahrenheit side. Remember, we always measure with Celsius. let's go ahead and try this out. If you're using a small cup like I am, we want to make sure that we're always holding on to our thermometer. So as we can see, the level, we hope we can see. Oh, I'm so sorry, you guys. This is really, really hard to read. Okay. As you can see, our level actually dropped. What is the temperature of our liquid? It's 11 degrees Celsius. What would my mistake have been if I said 52 degrees Celsius? Again, I'm looking at that left side, that's Fahrenheit. I only want to focus on the right side. And here I can see that it's one line above that big 10, which means it's 11. Good job. I'm going to put the camera down really quick to get our next liquid. Now that liquid that I showed you had ice cubes in it, so it was colder. This liquid is definitely hotter. We can see, right, with that red liquid inside rising, the hotter it is, the higher that it goes. The colder it is, the lower it goes. So right now it's trying to measure what our temperature is. So you can see it's slowing down. Let's just wait for it to stop where it needs to. All right. What is the temperature of the liquid? If you said 43 degrees Celsius, you are correct. Again, I'm so sorry for the lighting. This, as you can see, this thermometer is really, really small, so it's kind of hard to focus on it. All right, let's safely put our thermometer down and get our last liquid on deck. This one is definitely cooler than the last one, so we're actually going to be able to see that liquid start to go down. You see how it's decreasing? It's getting smaller. It's getting lower in temperature. Just gonna wait for that to slow down. Okay. Let's see. What is our temperature? It's 20 degrees. So if we see, it stops right at that bigger line. And I know that it looks like the 20 is next to the little line. So some of us might have said 19 degrees, but that big line, remember that big line is what counts by 10. And this 10 is the 20. So this is 20 degrees Celsius. All right, so that is how you take temperature with a glass thermometer. As I'm sure you probably figured out, digital thermometers are definitely a lot easier to do, but we want to make sure that we are able to use all sorts of different kinds of materials, which is why I chose to use this one today. In science classes, you also probably will be using this one from now on, just because, again, it's a really good skill that we need to practice. Reading numbers is something that's very easy that we do every day. This, not so much. So it's definitely a good skill to have as a scientist. And that was how we take temperature.